If I showed you this rock on the ground, most people would walk right past it. No sparkle, no shine, no reason to stop. It looks like nothing. Just another boring piece of stone you've seen 1,000 times before. But here's the strange part. Some of the most valuable metals on Earth, gold, silver, even diamonds, are often found in rocks that look exactly like this. Not beautiful. Not impressive. Nature does package treasure in shiny wrapping paper. In fact, geology works in the opposite way. The rocks that matter the most are often the ones people ignore. Cracked rocks, stained rock, ugly, rocks that look broken, stressed, or completely ordinary. That's because gold and other precious metals don't form at the surface. They form deep underground, under intense heat, pressure, and chemical reactions that take place over millions of years. By the time those rocks reach the surface, the gold inside them is usually locked away, invisible to the eye. No glitter. Just stone. This is why so many people walk right past valuable ground without ever knowing it. They're looking for shine, when they should be looking for damage. Geologists don't ask, does this rock look valuable? They ask, what happened to this rock? Was it fractured? Was it altered? Was it under stress? Because stress creates cracks. Cracks create pathways. And pathways allow mineral-rich fluids to move and deposit metals like gold and silver. That's the secret most people miss. Value doesn't appear where things look perfect. It appears where things were broken. So before we talk about rivers, gold pans, or tools, we need to change the way we see rocks. Because sometimes the most boring stone on the ground isn't boring at all. It's just hiding a very long story. Once you understand that ugly rocks matter, the next question becomes obvious. How can something valuable be hidden inside a rock that looks completely ordinary? The answer is simple. Gold and silver are rarely free. They are locked. Most precious metals don't sit on the surface waiting to be picked up. They exist in microscopic form, trapped inside stone,
Quartz veins,
iron-rich rock, sulfide minerals. To the untrained eye, these rocks look useless. To geology, they are storage. This is why crushing rock has been part of gold recovery for thousands of years. Not because people enjoyed hard work, but because gold refuses to be released easily. In many historic gold mines, the rock only contained 3 to 10 grams of gold per ton. That doesn't sound like much. But over time, that tiny amount built entire cities, economies, and empires. The key wasn't how much gold you could see. It was whether the rock had the right structure to hold it. When rock is crushed, its surface area increases. Hidden fractures open. Bound minerals break apart. And suddenly, something that looked worthless begins to reveal value. This doesn't mean every rock contains gold. But it does mean that gold often hides where people don't bother to look. Especially inside rocks that show signs of stress. Correction. Jagged edges cemented together. These features tell a story of pressure and movement. And pressure is where precious metals thrive. Here's where many people get confused. They assume crushing rock magically creates gold. Crushing simply reveals what was already there. Gold does appear because of force. It appears because geology decided, millions of years ago, to put it there. That's an important difference. This video isn't about telling you to break rocks at random. It's about understanding why certain rocks were chosen by nature to store value. Because once you learn to recognize those rocks, you stop guessing. And you start reading the land. Once you accept that value hides inside ordinary stone, the next step is learning which rocks are worth stopping for. Because not every cracked rock matters. But some cracks speak louder than others. One of the most important signs is broken quartz. Quartz by itself means nothing. But quartz that looks fractured, jagged, or crushed tells a different story. It means stress. And stress is how mineral-rich fluids move through rock. Gold and silver don't form randomly inside stone. They arrive dissolved in hot fluids deep underground. When those fluids lose pressure or change chemistry, metals fall out of solution and settle into cracks. That's why fractured quartz is so important. Not rounded. Broken. Another overlooked sign is iron staining. Reddish brown or yellow discoloration on rock surfaces often comes from oxidized iron minerals. Iron and gold are not the same thing. But historically, they travel together. Where iron-rich fluids once moved, gold often followed. This is why many gold-bearing rocks look dirty, rusty, or ugly. Nature isn't trying to impress you. It's leaving evidence. Then there are rocks that simply look wrong, angular fragments cemented together, jagged pieces that don't match their surroundings. These rocks are called brecciated rock. They form when stone is shattered and later re-cemented under pressure. That broken structure creates space, and space is where metals settle. To most people, brecciated rock looks like garbage. To a geologist, it's a red flag in a good way. River rocks can tell the same story. Smooth, rounded stones mean long transport and constant motion. Gold rarely stays there. But when you see rocks that are oddly shaped, cracked, or trapped behind larger boulders, pay attention. They're retelling you that movement slowed down here. And where movement slows, heavy materials begin to drop. This is where many people make a mistake. They look for one sign and stop. But gold doesn't follow single clues. It follows combinations. Fractured quartz plus iron staining. Broken rock plus trapped river material. Stress plus resistance. When these signs appear together, the ground is speaking clearly. The trick is learning to listen. Once you know which rocks matter, the next question becomes where to look for them. Because rocks don't exist in isolation. They sit inside systems. And gold only gathers where systems slow down. Rivers are the most misunderstood part of gold hunting. Most people assume gold is found in open water or wide gravel bars. In reality, rivers are transportation systems, not storage systems. Gold moves until something forces it to stop. The most reliable locations are where water loses energy suddenly. The inside curve of a river bend. Behind large boulders. At the base of waterfalls or drop-offs. Where fast water meets slow water. These are not random spots. Physics demands that heavy material settles there. Another critical location is exposed bedrock. When bedrock appears in a river or stream, it becomes the final filter. Water can move gravel. It can move sand. But it cannot move bedrock. This is where gold is pressed downward and trapped. Cracks in bedrock that cut across the direction of water flow are especially powerful. Slows. Pressure drops. Gold sinks. Over time, repeated floods don't remove the gold. They drive it deeper. Clay plays an important role here. When fine clay settles over bedrock, it acts like a seal. Once gold passes beneath it, the gold becomes extremely difficult to move again. These locations often look unremarkable. No spark, no dramatic features, just compacted material and rough stone. But they are persistent. One more sign people often miss is transition zones. Places where gravel suddenly changes size, where hard rock meets softer rock, where flow direction shifts. These transitions disrupt energy. And disruption is where gold begins to settle. The biggest mistake is searching where water looks calm. Gold doesn't care about calm. It cares about collapse. Once you understand where gold prefers to gather, the way you search has to change. This is where many people lose gold without realizing it. The most common mistake is scale. Digging too much, moving too fast. Assuming effort will replace understanding. Gold doesn't reward force. It rewards precision. Field studies and real prospecting experience show that nearly 80% of recoverable placer gold often comes from less than 20% of the ground worked. That means most of the ground people dig never had a chance to hold gold in the first place. Smart prospectors don't start by digging. They start by testing. Small test pans, shallow samples, focused checks on cracks behind rocks and compacted zones. Each test asks a single question. Can gold stop here? If fine gold appears consistently, the system works. If nothing appears after several careful tests, moving on is not failure. It's efficiency. Another mistake is chasing surface shine, bright gravel, clear water, clean stones. These places look good on camera, but they often tell the same story. Constant movement. And constant movement means gold never stays long enough to matter. Gold prefers controlled chaos. Broken, interrupted energy. Resist. This is why a narrow bedrock crack can outperform an entire gravel bar. It's not about how much ground you move. It's about how little ground you need to move in the right place. One more mistake is impatience. Rushing a pan. Overwashing material. Forcing speed. Gold is heavy, but fine gold is unforgiving. Once it's gone, it's gone. Controlled movement reveals gold. Aggressive movement hides mistakes. The people who consistently find gold aren't lucky. They're disciplined. They know when to stop, when to test, and when to walk away. Because walking away from bad ground is just as important as staying on good ground. At this point, one thing should be clear. Gold is not rare because it hides. It is rare because the conditions that hold it are rare. The Earth has been processing gold for millions of years. Every crack, every bend, every sealed layer follows logic. Most people search as if gold were waiting to be discovered. In reality, gold waits where it has no choice but to remain. These places are predictable. They follow gravity. They follow resistance. They follow structure. This is why gold remains valuable. Not because it shines. Not because it is beautiful, but because it is difficult to move, difficult to release, and impossible to create on demand. Gold accumulates slowly, resists change. It rewards patience. The same qualities that trap gold in stone are the same qualities that preserve its value over time. So the next time you walk along a stream, a hillside, or a pile of broken rock, pause for a moment. Don't ask whether gold might be there. Ask whether gold could stop there. Because once you understand that difference, you stop chasing signs. You start reading systems. And when you can read systems, you no longer rely on luck. You rely on understanding. That's where real discovery begins.